ask the questions, right? And I'm going to tell you the quiz questions. Any previous year questions you check from our banks, everything is directly from the report, correct? And you maybe noticed that all my quiz, it was from the report. You agree?
Yeah.
Yes? Did I bring any question from outside?
No.
Yeah, we can bring it, but we don't. So what I'm going to tell you, if you remember the quiz questions, the same kind of questions, maybe the number will be different. Maybe the same question is going to come into the final. You get it?
Yes.
Yeah.
So, and our pattern is half of the questions will be the numerical questions. Why? Because we are not going to do the exam at one time. For the whole week, the same exam bank is going to run, but it will change a bit and after 2 sections or 1 section. It's a different story. But what I, from my experience, what I know is we have a limited content only, because in every experiment there is an objective, right? We are directly going to the objective. And if you know how we reach the objective, you are done. So let me introduce you this. What we did in the fine measurement? What we did in the fine measurement? Tell me. I mean, in the fine measurement experiment, the first thing is you need to know how to use the micrometer and the vernier, right?
Yeah.
So that means how I can bring question from that. Just bring a picture, like what I did in the quiz, right? I can bring pictures, then I can ask you to read it. Is it a big deal?
No.
You know how to read. If not, sure, I will bring questions like that. You need to practice. And that's what we did there, right? Then we ask what was the objective of our fine measurement. I ask you to find density. What is the equation for density? Density is mass by volume.
Yeah.
So basically, we had two, specimens, right?
Yeah.
Cylinder is the most one we use, right?
Yeah.
What is the equation for this density of a cylinder?
4m by
ala
d square h.
by d square h, right? M indicates mass, d diameter, h height. And you know that all our answers, not specific. Majority of physics answers, you know that final answer will be in terms of SI units, right? Because some of the quantities will be definitely in SI units. So definitely, or we will specify in the question, right? The final answer in centimeter. And today one of the question, I will tell you, today's one of our quiz, one question, the final answer I am asking you to write it in centimeter. So be careful. Okay, next. So how will you calculate the density? You know the mass, you know the diameter, you know the height, correct? Substitute. Agree? Okay. What is the next thing we did in this?
Cylinder,
Yeah, sphere or whatever, right? There is nothing more that I can ask. If you are going to do this experiment, I will bring such questions only. Because that's what only we did in the lab, right? So what is the next experiment? So we moved from 1 to 2. What was the next experiment? In our list, it is force table. Agree?
Oh, yeah.
Yes? What we did in the force table experiment, anybody remember? The force table was
we had
a table like this, correct?
Into equality.
And there is a ring here.
Oh, yeah.
What we did into the ring, we apply two
forces, yeah.
Imagine if I'm going to
Different
apply
direction.
these two forces.
Doctor, question 1, Formula 1. Do you see the equal there? Equal? The left it, what's it called? Up.
Density.
Density?
Rho. Yeah.
D يعني.
Density rho. Okay, so this is the force table. How many quadrant here we have?
4.
4 quadrant. Imagine, you remember that in our experiment we apply two forces. Imagine if I'm going to apply one force here, F1 in the 3rd quadrant and F2 in the 3rd quadrant. Which direction the resultant force will be?
Third.
The resultant force will be 3rd quadrant.
Yeah.
So
Yes.
this is FR. And how we measure the resultant force during this experiment? Did we measure the FR directly or we measure the F equilibrium?
Equilibrium.
We balance it, right?
Yeah.
So the balancing force will be exactly opposite to the resultant force. We call the F equilibrium, right? What we know that F equilibrium is in which quadrant, FR is in which quadrant. I ask such questions in the sample exercise, right? So this is one of the type of questions there, right? So you remember the sample exercise questions? You need to have a look into that, okay? So tell me which direction these two resultant are?
Opposite direction.
No, which direction or which quadrant?
Third.
3rd quadrant. Which direction the resultant, equilibrium?
First.
3rd quadrant. first quadrant, so yeah. So you understand these.
Yeah.
So we will solve these kind of questions. The result FE is in first quadrant, FR is in third quadrant, and the resultant force is always in between the two forces. You remember this experiment,
Yes.
right? Yeah. And in addition to that, this was the experimental part. How we approach this theoretically? Yes, we ask you to calculate the F resultant, correct? And you notice that in order to find the resultant force, each force you split into components. That means if the force is F1, you split this F1 into two components, right?
Yeah.
One is F1x, the other one is
FY.
F1y. And all of you know that F1x is the cos component, right?
Yes.
So it was F1 cos theta. The same way you have F2x. Same way you have F2y and F1y. And when we add these two, we get the x components.
And the y.
And here you get the y
Y
component of resultant.
Square.
Then you understand the resultant force we calculated using the Pythagoras theorem, right? Rx square plus Ry square, square root of, right? Then we notice that the theta, the angle of the resultant force with respect to the axis, x-axis is tan inverse
Y over X.
Ry, resultant y, resultant x.
X.
And that was our experiment, right? In that, there were a few things. We noticed that the resultant direction and the equilibrium direction are opposite. So in one of the question, if I bring, if the resultant force is at 20 degree, which direction will be the equilibrium?
There.
Why you need to add 180, right? Such questions I can bring, right? I'm exploring the kind of questions we can ask. You get the point? So you should ask yourself, oh, how he can make questions? And I'm going to tell you something else. I'm not going to bring questions outside from the report. Whatever we did in the report only, I will ask. Okay? Clear about this experiment?
Yes.
Now we can move to the third experiment. What was the one?
Doctor, didn't we have uncertainty in lab 1?
Uncertainty calculations you know, right? Yeah, maybe. You try. What is the third experiment?
Free fall.
We have the free fall experiment, right? What we did in the free fall, actually
Drop,
from free fall, we are going to introduce you the relationship between f and x, right? We know that y is, if y axis value or the thing that we are going to consider in the y and x, if they are directly proportional, what we will see, we will, all such problems, we will plot a graph of y versus x. You notice that it is going to be a straight line, right?
Yes.
And we always deduce the final answer from the slope. You remember that? Okay. Now, this is what I want to tell you from now. None of these questions you don't need to by heart anything. Only just to know the first step.
Formula.
Then you reduce. Then you deduce. Otherwise, you will be in trouble because we always swap the axes and all. Then it's very difficult for you to memorize. So, what is the best to try? The best way is just understand the basic equation and do one step. Then your answer will be in your paper. I will show you how long I am going to take. Look the time. Okay, what was this experiment? We drop an object, right?
Yeah.
From this point. You notice that this object is traveled a distance of how much? D. And how long it take?
T.
It took t seconds, right?
Yes.
And we can use this information. I have three things. The initial velocity is 0, and I know d, I know the time. Then I can use this information in the kinematic equation, which represents displacement and time. Tell me, what is that relation? Delta y, because it is in the y direction. Delta y is v initial y times t plus half
GT.
gt square. Is this equation is familiar to you?
Yes.
All of you know, right? Only this equation you know, you are done. Now look here, what is initial velocity?
0.
What is delta y today I call?
D.
D equal to
Half GT.
half gt square. This equation is familiar to everybody, or most of you know this. Either you remember this equation for this experiment or start from there. It's up to you. So you only need to start from this and just memorize this or remember it. I don't want to say d equal to half gt square. Done. Now you look. G is a constant, right?
Yes.
Is it that format? Because if G is a constant, we can say D is proportional to
Half,
T
T
square.
square.
You agree?
Yes.
Now,
The slope is half G.
now I have a freedom because I notice that this I am going to consider in the y-axis and t square in the x-axis. So I have that relationship, pure relationship, right? So here we do some trick. We use the swapping the axis. You notice in our course, right?
Yeah.
What I can ask now? I can ask you to plot d according to that. D in the y-axis, t square in this x-axis. Alatur you will see a straight line, and the slope will be,
Half
because this is
g.
m, y equal to m
X.
x. So m is the slope. The slope will be what?
Half G.
Half g. And then from this information you could reach the objective. What is objective?
Point
Get
G.
g. What is g?
2 slope.
2 times slope. You understand how we did this experiment?
Yes.
Now what we do in addition to that? What we do in addition to that? We swap the
Axis.
axis. If I do that,
It will be
what
2
will be
over
the
G.
answer? We did it in the quiz, you remember?
2 over slope, yes.
If I flip this, it is going to be, the slope is going to be,
2 over G.
if it is g over 2, it will be 2 over g. No need to worry much.
Oh, okay.
Because you are based on this, you are talking this. You understand? Better one from one move to the other. No need to make complicated. So, what is this g then? G
2
is
over
equal
slope.
to 2 over slope. So, you could calculate. So,
Yes.
but one more hint. I mean, because when I examine your papers, so many times I noticed this. When we ask G, what is G? Acceleration due to gravity. Everybody know the value of G, right?
Yes.
It is 9.8. And somebody get 97 or 198 or something like 3.3. Do you think it is
Not gravity.
relevant? Yeah, so you think, yeah, because so someone who makes questions, you know, he is actually bringing some real data. You understand? So if you are not getting the right answer or in that range, you should know you had a mistake, right?
Yeah.
Then you look into your problems, you could easily figure out your mistake. You understand that point?
Yes.
It's a very valid point. Understand?
Yes.
Are you sure?
Yeah.
Okay. So this is clear, boys?
Yeah.
So we already have questions from this in the last week's quiz, right? So can I move forward?
Yeah.
Yes.
Okay, so we're done with this, right? What's the next experiment? This is about simple, sorry, it was,
Projectile?
Kinematic?
yeah, next experiment is kinematic motion, right? The simple experiment, what was that? If an object is in an inclined plane,
Oh, yeah.
if an object is in an inclined plane, you know that the object is accelerated
Yes.
since the two forces acting on that object. One is the weight mg,
H
right?
time.
And this weight mg we split into components.
Yeah.
And this is the component is in the horizontal direction. If this is mg and this angle is theta, we know that it is mg sine theta, and the component, the normal
Normal
force.
force.
What is that? The normal force is what?
Equals
mg cos theta,
theta,
right?
yes.
So the normal force is mg cos theta, and the horizontal force is mg sine theta. You remember it, right?
Yes, yes.
It is in the video, right? Now, which is the driving force?
Sin theta.
Mg sine theta, and that force, according to Newton's second law, equal to that force mg sine theta is equal to, according to Newton's second law, it is
MA.
ma. So m and m cancelled, you get
A
a equal
equal
to
G sine.
g sine theta, and the rest story is well known to all of you, right?
Yeah, H2
What is the
minus
next thing? Yeah, the sine theta we measure from the height h2 and h1
Okay.
and the distance between these 2 points d.
D.
You know that is equal to g into h2 minus h1 a la d. We had few questions in the quiz, right? Everybody know this. Any
Yeah.
doubt about this?
No.
And the experimental part, this was the theoretical part. In the experimental part, what we did, we calculate the acceleration theoretically for a particular inclination. Then we verify that from the velocity time graph and the xt graph. All of you remember the shape of velocity time
Yes,
graph.
straight line.
Yeah, being a uniformly accelerated motion, it will be a straight line and the slope represents acceleration. What about the xt graph?
Parabola.
It's a parabola, right? And what was the equation of a parabola? Ax square plus bx
Plus C.
plus c. You notice that this a is the coefficient of t square, right?
Yeah.
So this is half a.
Slope equal.
The half acceleration is equal to that capital A in that. So a is 2 times
A.
capital A. You remember?
Yes.
Here directly acceleration. So we compare these two with this result. What's the problem?
Nothing. We're explaining how we do the exam.
Yeah. So you understand this? This
Yes.
is about the kinematic motion. Solved enough? So can I move